Okay, here is 7.3.1, and this is 8th grade. And there's only a few more lessons in this chapter. This is one of the last that we're going to go through. And let's get started. So it's called How Can I Use an Equation? And it says, previously you've learned to find and extend patterns in data and to make predictions using rules, equations, and graphs. Today you will apply these mathematical tools to a real situation in which your data does not make a perfect pattern. I've pre-drawn my graph already, but we're not there yet, but I pre-drew it just for the sake of time. And that'll be part B of this problem, I think. So it says, Orly's bike ride. Prepare for a 30-mile ride for charity. Orly has been biking every weekend. To predict how long the charity event will take her to complete, Orly has been keeping track of her time and distances. She tries to ride at a constant pace, but of course, that is not easy to do. So then, let's see if I can scroll down. Okay, so it gives us this table of her data, and it has like the weekend, the time in the next column, and the distance in the third column. So it's giving us like February 6th down to March 13th, and gives us time in minutes, distance in miles. So part A says, would a box plot, scatter plot, or histogram be most useful in helping Orly make a prediction? Well, if we think about, we've got two variables here. We've got the time and distance. So if you were to use a box plot, if you recall previously in this chapter, we talked about box plots, not for very long, but a little bit about them, and they are useful. Remember, they kind of look like this. They are useful if you have one variable that you're working with, or one set of data, pretty much. So if you have like your data is 2, 4, 6, 8, 10, then you could use a box plot, but it's giving us 2 columns of data. So this would be like 1 column of data. So a box plot would be no good. A scatter plot, and I saw on somebody's work that a scatter plot would actually be the best, and that is the correct answer. And the student said that it's because the data is scattered, which is actually kind of a good explanation for why you would use a scatter plot, because it's not going at like a constant rate. It doesn't look like. And if it was like going by 2s or going by 4s, then you would just draw a linear line. But since it's a scatter plot, the points are scattered. So that would be the best representation of this data. A histogram would be no good, because a histogram is like this. It's kind of like a bar graph, but then you have like intervals between like 0 and 2, and then you have like between 3 and 5, and then it would be like a box, kind of like that, kind of like a bar graph, and that's not going to be very helpful for this graph or this data, because there's no like span of, there's always like a span or interval down here, and we don't have that in this data. So a scatter plot would be the best option. So part A would be scatter plot, and the reasoning is because the data is scattered. It's a pretty good explanation, and you've got two variables that you're working with. Okay, so part B says, considering that Orly is trying to predict how long it will take to complete the ride, which is the independent variable and which is the dependent variable? So if you think about independent and dependent, independent, can like stand alone, and then dependent is like somebody who needs another person or needs this thing to survive or change. So we need to pick the time or the distance as our dependent and independent variables. Whoa. Ugh. You could also think about it, an independent variable might be like the cause, and the dependent would be the effect. So let's see. We've got time and we've got distance. So I put on my paper that I thought time would be the dependent variable and the distance would be our independent, because we're not manipulating the distance, because she has a specific distance to go. She has 30 miles. That's the entire race is 30 miles. So we're not changing the 30 miles. She's not changing the amount of distance she's going, but the time depends on the distance, because the time, we have no idea what her time could be. The problem didn't tell us, and that's the time is depending on the distance. So our independent is the distance, and our dependent is the time. So that means, and now it says to make a scatter plot, and this is all part B still. So here's my graph that I started. I did distance on the X, and I did time on the Y. And then I did on the X, I went by 5s up to 30. And then on the Y, I went by 25s up to 150. Hopefully you can kind of see that, hopefully. So now I'm gonna quickly graph my points. So I'm gonna start with February 6th. So it looks like we went, the distance is 7, so I'm gonna go about right here, up 68, which will be about right here. 17, so on February 13th, go over 17, up 88, maybe right here. February 20th is 3.5, so that's gonna be over here, up 35. I'm gonna put it right here. February 27th is 25, up 150. That's all the way up here. March 6th is over 14, up 104, right there. And then March 13th is over 11, up 80, right there. So there's our scatter plot, and that's satisfying part B. Part C says, well, let me move it down. Use a line of best fit to predict how long it will take Orly to complete the charity ride. Remember, the line, and I'm just reading from the book, the line does not need to intersect each of the points, and the line does not need to pass through the origin to model the data. So it does not have to pass through 0, 0. And I actually used the e-tool on this to get it more precise, and it was kind of easier to work with, but I also did it on my paper, so it was pretty similar. So if you want to do it online, you can, but it wants us to draw a line of best fit. So let me see. I'm gonna draw it. Sorry, I'm gonna move in front for a sec. There's my line of best fit, and it's a little crooked and it's not supposed to be, but I can't draw straight. So there's my line of best fit. It's showing the pattern of the data, and it's pretty even. This guy's kind of out here. I could have maybe drawn it a little bit. Yeah, I think I'm satisfied with my line of best fit. It's not going to be precise, but that's pretty much the gist. That's the gist of the line of best fit. So then it also says to determine, for part C, we're still on part C, predict how long it will take her to complete the charity ride. So the whole charity ride is 30 miles. So I know down here, I have 30 right here. So if I want to predict how long it might take to complete the ride, I'm gonna make like a little dotted line going all the way up, and it reaches my line of best fit. And it looks like, whoa, that was weird. It looks like it's intersecting my line of best fit at about I don't know, maybe 170. That looks to be about 170, yeah. So I'm gonna put approximately 170 minutes to complete the race. And that's how you use a line of best fit to predict an outcome. If you know the X. If you know the X, but you don't know the Y. Okay, and that was 787. And now we're going to move on to 788, which is the last problem for this lesson. And I think I want to keep my graph there, but I am going to erase this. And I'm also going to erase this, that. Yeah, so that's all I'm going to erase. And then my next problem is going to use this information still, so I kind of want it there. Okay, 788. Sometimes it's more convenient and more accurate to use an equation to make a prediction rather than making a prediction by reading a graph. So part A says to choose 2 points that lie on your line of best fit. The points can be given data points or lattice points on the coordinate grid. Use these 2 points to calculate the slope of your line of best fit. What does the slope mean in terms of her bike riding? Okay, so first of all, we need to choose 2 points that lie on this line of best fit. So I took my points off of the e-tool because it was easier to see the grid, but it's not, and everybody who does this lesson, if you've already done it, you might have different answers, and that's fine because our graphs are not completely accurate, and we might be a little off in our line of best fit. And plus if you're not using the e-tool, you might not have graph paper, so you're just using regular paper. So here's the points that I found that would probably be on this line of best fit. So I found these 2 points, 6, 50. So over 6 up 50, and it doesn't, it kind of works on this graph that I made. So 6, 50, and then I found another point, 17, what did I do? 17 up 110. And that kind of fits. So the reason I picked those is because when I saw it on the e-tool, this one was like on the grid and it intersected the grid, and so did the 17. So I went over and then up, like slope-wise. So here's our X, here's our Y, here's our X, here's our Y. And it says find the slope. So we need to find the slope given just 2 points. So this is 1 point and this is another point. In order to find the slope, remember slope is the change in the Y over the change in the X. And it's in that form. So we need to figure out, let's look at the X's first. 17 is the first, or 17 is one, and 6 is the other. So we need to figure out the difference between 6 and 17. So you can just subtract them. 17 minus 6 gives you 11. So that's our X. And then our Y would be the difference between 50 and 110. So 110 minus 50 is 60. So now we have our X. Our X is 11 and our Y is 60. So now we can plug it into our slope. So our slope would be 60 over 11. So all the slope is telling us is, and it says, what does the slope mean? So the slope means that for every 60 minutes, she goes 11 miles. That's what that means. Because the X, here's our X-axis, and the X is on the bottom, and then the Y is our vertical, and it's 60. Here's the Y, here's the X. For every 60 minutes, she goes 11 miles. Okay, that's how you find the slope between 2 points. So if it asks you on a test to find the slope and it gives you 2 points, you know to just subtract the bigger number from the smaller number for the X's, and the same thing with the Y's. And then put the Y on top and the X on the bottom of the fraction. Y over X. Okay, I'm going to erase this. So that was part A. Part B, it says, what is the y-intercept of your line of best fit? What does the y-intercept mean in terms of her training? So the y-intercept, if we look at the graph, we want to see where approximately it's crossing the y-axis, and it's right about here. So if I go up, that's probably what, about 22, 23? I would say 22. So let's pick the y-intercept is 22, or you could write it as the actual coordinate like that. And then what does it mean? What does the y-intercept mean? So what I figured is if you look at the graph and you know that the x is 0, but the time is 22, so that means the 0 represents distance. So it looks like she's not moving. Well, she isn't moving because it's 0. So the x is 0, the y is 22. So she's not moving, yet it's been 22 minutes. So here was my reasoning. My reasoning was the 22 represents her taking a break from biking, and she started timing herself after 22 minutes of taking a break. Okay, so that, or you could say like she started timing herself after 22 minutes. I guess that's the only thing she could be doing is taking a break. I don't know. She could be at a cafe. Who knows? She was at the cafe for 22 minutes and then she started timing herself. Okay. So that was part B. Part C is asking us to write the equation now in y equals mx plus b form. That's our y-intercept and that's our slope. And we know the slope. I'll write it again. What I got was 60 over 11. So we can just plug these two values into our equation. Keep the y, we don't have the y value. So y equals the slope, 60 over 11x, plus your y-intercept, plus 22. And then the variables, it says to identify the variables. I'll erase this thing. So the y and the x, it says what do they mean? So the x is and the y is. And we already talked about that before. The x is the distance, y is the time. So that's part C. Lastly, it's asking us to use our new equation to predict how long the charity ride would take her. And we know that the total charity ride is 30 miles. So I'm going to erase this and this and this. So now it's part D. And we're actually going to take our equation, we're going to plug in for x, we're going to plug 30 because that's the total distance and x is our distance. So we're going to rewrite it, y equals 60 over 11 times 30 plus 22. And then if you plug it into your calculator, which I'm going to do right now. No, that's my Fitbit. 60 divided by 11 times by 30 plus 22. Okay, so I got y equals one. I'm not going to put equals. I'm going to put approximately 185 minutes for the whole race. Okay, so I put approximately because ours might be different, yours might be different, the books is different, but we're kind of in the same ballpark. And it says, how did your prediction that we made over here compare to the prediction in part C? So this would be our prediction now, and that was our prediction before. So it seems to be pretty close in value. 170 and 185, not too far off. so it looks pretty accurate to me. And I didn't assign the learning log, but I'm just going to go over it really quick so we can kind of summarize what we've been doing. I'm going to use a different color. I'm going to use purple. Hopefully it shows up. Okay, so 7 dash, pretty nice. 7-90. Oh, I already have it on my paper. I titled it Line from Data Points. And the actual learning log is asking, describe how to find the equation of a line in y equals mx plus b form from a graph of points. Include an example of how to calculate the slope from 2 points. Okay, so here's what I wrote. I said you can find 2 points on your line of best fit. To find the slope. And I put mx to show that that was that part of the equation. And then find your y-intercept. Which is your mx plus b. And if you had the 2 points that we used before, for example, what points did I have? 5 and at 650, and I had 1710. xy. So you would take for the x 17 minus 6, which is 11. For the y, you would take 110 minus 50, which gives you 60. And then if you put it in slope form, it would be 60 over 11. It's the slope. So that's kind of closing up what we did today. And I believe that is it for this lesson. So there's 2 more lessons in this whole chapter, and then we will move on from there. Thanks for watching.